On your screen is a simplified structure for the BJT. It consists of three semiconductor regions: the emitter region N-type, the base region P-type, and the collector region, again N-type. This transistor is called an NPN transistor. A terminal is connected to each of the three semiconductor regions of the transistor, with the terminals labeled E for emitter, B for base, and C for collector. A dual also exists called the PNP transistor, where the emitter region is now P-type, base is N-type, and the collector region is also P-type. Now the transistor consists of two PN junctions, the emitter base junction and the collector base junction. Depending on the bias condition of each of these junctions, four different modes of operation of BJT are obtained. The first one is the cutoff mode, and it is caused by the emitter base junction and the collector base junction both being reverse biased. The second one is the active mode, and this is caused by the emitter base junction being forward biased and the collector base junction being reverse biased. The third one, reverse active, is caused by the emitter base junction being reverse biased and the collector base junction being forward biased, as the name suggests. The last one, saturation, has both the emitter base junction and the collector base junction in forward bias. Now the active mode, also called the forward active mode, is the one used if the transistor is to operate as an amplifier, while the cutoff and the saturation modes are used when the amplifier is to be used as a switch. The reverse active mode has very limited applications. Now you may be wondering why the BJT is called a bipolar junction transistor. It is called bipolar because charge carriers of both polarities, that is the electrons and the holes, participate in the current conduction process. It is called a junction transistor because the conduction depends upon diffusion of both holes and electrons across the junctions. No channel for conduction is created in the BJTs.